Today, we're literally rolling up our sleeves to tackle what I consider the absolute unsung hero of your powertrain, the flywheel. As a mechanic, I see these fail all the time, and we're going to talk about exactly how to diagnose that failure before it completely destroys your transmission. So, if you've been wrenching for a while, you know this heavy piece of metal sitting between the engine and the gearbox does a lot of heavy lifting. Today, we're breaking down what goes wrong, how you can spot the symptoms, and most importantly, how to fix it the right way.
Right off the bat, let's look at this quote. Because as any veteran mechanic will tell you, a catastrophic drivetrain failure always leaves breadcrumbs. I mean, these parts don't just explode out of nowhere, right? They actually talk to you. They give you warning signs, sounds, smells, weird vibrations that build up progressively over thousands of miles. The real trick here is knowing how to listen to what the car is telling you long before a minor repair suddenly turns into a massive, wallet-draining transmission rebuild. All right, here's our repair order for today. Section 1, the powertrain's unsung hero. 2, symptoms from the driver's seat. 3, under the lift, diagnostic checks. 4, single versus dual mass failures. 5, the resurface versus replace dilemma. And finally 6, precision assembly and installation.
Okay, jumping right in. Section 1, the powertrain's unsung hero.
Think of the flywheel as your engine's ultimate multitasker. It's this heavy, precision-machined disc bolted right to the back of the crankshaft, and it's doing like 3 or 4 jobs all at once. It's storing kinetic energy to smooth out the violent power pulses from the cylinders. It's keeping the rotating assembly perfectly balanced. It provides the ring gear for your starter motor to grab when you turn the key. And, crucially, it's the primary friction point for your clutch. When this thing is healthy, your ride is buttery smooth. But when it's not, oh man, you are definitely going to feel it. Let's move on to Section 2, symptoms from the driver's seat. So you don't even need a lift yet for this part. Here's your sensory checklist. First up, feel. If you're letting the clutch out, especially on a hill start, and you get this violent, rapid shudder vibrating right through the floorboards, yeah, that's clutch chatter. Next, smell. If you catch a sharp, acrid smell, kind of like burning paper mixed with hot metal, that's your clutch slipping against a damaged flywheel. Then, listen. Getting a heavy metallic rattle at idle on a diesel, or maybe your starter just whirs and grinds but the engine doesn't crank, these are your absolute first warning signs that things are going sideways. This diagnostic flowchart is basically our shop cheat sheet. It connects exactly what the driver is complaining about directly to the mechanical fault we need to hunt down. Customer comes in complaining about clutch chatter, boom, we're instantly looking for hot spots or warped surface. If they're complaining about gears grinding or locking them out of first, we know we've got a measure for excessive lateral runout. And if that starter is just spinning freely, we're going straight for the ring gear to hunt down worn or sheared teeth. All right, time to get our hands dirty. Section 3, under the lift, running our diagnostic checks.
Once that gearbox is dropped, we're doing a visual inspection for what I like to call reject territory. First thing, radial cracks. If you see cracks radiating outward from the center, that part is instantly garbage, mandatory replacement. A cracked flywheel under high RPM load can literally disintegrate like a grenade, and you do not want to be near that. We're also checking for deep grooves worn past 0.5 millimeter, and obviously oil contamination. A leaking rear main seal will soak that porous cast iron, and your friction coefficient drops from a grippy 0.40 right down to a totally useless slipping 0.05.
Now, heat is the enemy here. If you're inspecting the friction face and you see these blue or purple heat spots, man, that means localized temperatures exceeded 300 degrees Celsius. That's roughly 570 degrees Fahrenheit. That kind of extreme heat permanently alters the molecular hardness of the metal in those specific spots, meaning your brand new clutch will never ever grab evenly against it. It causes that terrible shuddering we just talked about, and it's a great way to guarantee a very angry customer coming right back to the shop.
Next up is measuring surface runout. Runout is basically the lateral wobble on the clutch face as the whole assembly spins. When a driver says, hey, it's hard to get into gear, or they get gear clash, even with the clutch pedal mashed firmly into the floor mat, surface runout is usually the hidden culprit. Because the flywheel is wobbling side to side, it keeps nudging the pressure plate open slightly, which totally prevents full clutch disengagement.
So how do we check it? We mount a magnetic base precision dial indicator right to the engine block. Rest that little needle against the outer edge of the flywheel face and slowly rotate it by hand. The absolute maximum acceptable lateral surface runout is usually a microscopic 0.05 to 0.15 millimeters. Seriously, to put that in perspective, anything beyond a few thousandths of an inch, literally thinner than a human hair, is reject territory. You've got to machine it or replace it. We also can't forget the ring gear.
Because starter motors tend to engage in the exact same spot every single time you start the car, you get this crazy asymmetric tooth wear. To inspect it properly, follow these exact steps. Pull the spark plug so you aren't fighting engine compression. Put a big breaker bar and socket on the front crankshaft bolt. Slowly rotate the engine by hand and inspect every single tooth through the starter motor hole. Do not skip this step.
Moving right along, Section 4. Single versus dual mass failures. So, knowing what you're working on is half the battle. Standard single-mass units are basically solid chunks of metal. They fail from surface heat, warping, and glazing from a slipping clutch, and a lot of times they can be resurfaced. But modern dual-mass flywheels, or DMFs, which are super common on diesels and turbo setups now, those have internal spring packs and damping grease. They fail when those internal springs physically break down. It causes this awful, heavy metallic clunking at idle that kind of mysteriously smooths out when you rev past 1,000 RPM. To verify a dead dual-mass unit, make sure the transmission is in neutral. Reach in, grab the ring gear, and try to rotate that secondary mass back and forth. If you feel more than 15 to 30 degrees of rotational free play, those internal damping springs are totally shot. And here's the hard truth, guys. You absolutely cannot resurface or rebuild a dual-mass flywheel, period. If it fails this free play test, the unit is garbage. Full replacement is your only option.
Which brings us to the workbench for Section 5, the resurface versus replace dilemma. So, do we send it to the machine shop or buy a new box? Resurfacing, grinding the face flat again, is only viable for solid flywheels if there are absolutely no cracks, the grooves are shallow, and the final thickness will still meet the manufacturer's minimum stamped specs. But total replacement is both legally and mechanically required if you find radial cracks, if it's a dual mass unit, or if you've got that severe deep blue heat discoloration. Look, resurfacing might seem like a steal at $20 to $60, but if you cut a flywheel too thin, you ruin its rotational balance. And that's going to cause a massive, nasty vibration through your entire drivetrain at higher RPMs.
And that perfectly tees up what I call the labor trap. Look, dropping a gearbox takes anywhere from 3 to 8 hours of heavy, backbreaking labor. Here is the brutal economic logic. The labor cost massively dwarfs the price difference between resurfacing an old part and just buying a brand new one. Being cheap and not replacing both the clutch and the flywheel simultaneously is just a huge financial mistake. An old, glazed flywheel will instantly chew up a brand new clutch disc. Worse, a vibrating, unbalanced flywheel causes cascading damage, eventually tearing up your transmission's input shaft and bearings. Trust me, proactive replacement saves thousands in the long run.
Okay, the new parts are here. Section 6, precision assembly and installation.
Let's say you did have a single-mass flywheel properly machined. Well, the friction surface isn't supposed to just be flat. It actually requires a highly specific mechanical tolerance. We're looking for a surface roughness, or RA, of exactly 0.8 to 1.6 micrometers. If the machine shop makes it too smooth, your brand new clutch is going to slip the second you hit the gas. But if they leave it too rough, it acts literally like sandpaper and will destroy your new clutch disc in just a few weeks.
When you're bolting it all back up, there are very strict rules. First, throw away the old stretch bolts. Never ever reuse them. Second, apply fresh thread locking compound, something like Loctite 243, to the new bolts so they can actually withstand the insane drivetrain vibrations. Third, tighten them down in a specific star or cross pattern so you don't warp the new disc. And finally, use a calibrated torque wrench to bring them to exactly 40 to 85 Newton meters. But always check your specific manufacturer's manual for that exact spec.
I cannot stress this enough. A loose flywheel bolt will back out, shear off, and cause immediate, catastrophic engine and transmission damage. It is a nightmare. Unless you've got the exact precision tools, a proper automotive lift, and deep transmission experience, leaving this complex job to the professionals is truly the only way to guarantee you won't tear your engine apart on the very first test drive. So, as we wrap up today's explainer, I want to leave you with a question. When your vehicle's already up on the lift, torn apart, and you're staring down the barrel of an 8-hour labor bill, are you really willing to risk destroying your entire transmission just to save a few bucks on a questionable resurface job? Listen to the symptoms your car gives you, inspect those parts meticulously, and always, always prioritize long-term reliability over a cheap, quick fix.